Dr. Chuck the Science Schmuck.
Synchronize. So right, yeah, bananas. Interesting thing about a banana, it's botanically a berry. Yes, that's the boringest trivia ever. Saying a banana is botanically a berry is like saying a dog is botanically a mammal. Uh, I don't know if any of you have ever seen a banana plant. I used to have a very nice one. It died a couple of years back. They're not trees per se. They're kind of like a shrubby thing. Very tall, big leaves. In Texas, we used to have them everywhere, but you couldn't eat the bananas off them because they weren't edible, technically. I saw the banana farms in Peru when I was there many decades ago. Just banana trees, and one of these comes in like a giant thing that's like this big that hangs off the plant. But what am I going to do with this banana? No, not that. What I'm going to do with this banana is I'm going to attempt to fossilize it. Now this is probably going to take several episodes because this is going to be like a 6-month process. Because fossilizing a banana is not easy. Now, admittedly, I'm not a big fan of wasting food. This is probably a very delicious banana. It's not ripe yet to the level I would like it, but this banana must be made sacrifice to allow for bananas to be known into the future for posterity reasons. It smells like a banana, kind of. I'm not actually the hugest fan of eating bananas. I do like them dried, but they have a really weird texture. Interestingly, same calories per dollar as ramen noodles. So bananas are as cheap as ramen noodles, 49 cents a pound around here. So, what is the first step for processing this banana? Well, the banana is alive, so to speak. It's made of living plant material, so cell walls which need to be desiccated of their moisture. That's the first step, is desiccation of moisture, aka mummification. Now, how do we mummify a banana? This is a problem that every person in the entire world asks at least 3 times a day for their entire life. Nobody is ever like, I'm not going to think of how to mummify a banana. Something I think about a lot. First, goggles, because this involves some corrosive chemicals. The chemical in question is this, salt. Just like the ancient Egyptians. The ancient Egyptians would, later in their mummification stages, part of the mummification process involved putting the body of the deceased in salt to desiccate it, supposedly. I don't know where the Egyptians got that much salt. That probably would be for wealthier people. I mean, probably the theory of mummification evolved from just burying people in the desert and they dry out and they get mummied. This specific salt is a mixture of sodium chloride and calcium chloride. Up here in New York, this is commonly used to melt ice because our temperatures right now, I actually had to wait all day for the temperature to get high enough to film because my furnace is running constantly. It's like 8 Fahrenheit outside, so very much below 0 Celsius. This is usually required to melt. The point being, it's super cheap, the most economical source of non-food salt you can get. I will probably be in the future using it as an electrolyte for various reactions that require electrolytes. Let's see what you definitely don't want. It's not what you would expect it to smell like. It's fruity. You don't want to touch this with your hands. You don't want to get it everywhere because this stuff will mess things up. It's salt. It's little crystals. It says clearly on the side not to taste them. I don't know what's in it because this is not food grade, so don't actually eat it. Regardless of whether or not it's food grade, it'll work fine for this. A container. A nice salty bed. Oh, my hands are getting dry just touching it. We insert the banana. And then we cover the banana completely. And it's 20 pounds. Plus, this doesn't actually expend the salt. I can use that salt for whatever I want. I can use it to melt snow or ice. I can use it for electrolysis. I can use it for whatever I want. It'll just be banana flavored, vaguely. Again, don't eat it. Oh! Very salty. Don't eat it. Oh, it's shiny. There we go. This is probably going to take a couple weeks. This is a video I'm filming while simultaneously filming a few others, so this will take a while to dry out. Set that aside. And now I'm going to flash forward in time. Well, I'm back. I finished baking the banana. I did have to bake it. Apparently it takes forever to salt a banana. Wouldn't have thought it. Probably should have thought it. Interestingly enough, I looked it up. The Egyptians didn't use, road salt on their mummies. They used something called natron, or natron? Not Egyptian, I can't pronounce things. It's a crusty stuff that forms on the desert. It's sort of like alum, so it's much more hygroscopic. So it gets out in the desert, it's dry, you collect it, it absorbs moisture. Also, the Egyptians didn't just shove a guy in there, like, just grab him by the feet and just into the salt. Apparently they would gut them and then store the organs if you were wealthy, otherwise they sort of just got rid of those. And then pack them with the salt them into jerky. Then they'd finish the mummification process. Apparently there were tiers, like it was required that you get mummified, but not like religiously required that you get mummified, but you didn't have to do it fancy. Like not everybody got a big tomb. A lot of people just got dried out and shoved in a hole just to keep you nice and dry. So I did have to cook the banana slightly, not to a high temperature that would, fry it, but enough to get it baked. The salt is kind of congealed. Find that banana. There it is. And it rises from its tomb. It has blackened slightly. It's got to smell like a baked banana. Like, not good. It's leathery. I mean, I imagine this is what a mummy feels and looks like after they've been dried. They get blackened and leathery and a little bit salty. I'm sure they didn't taste the mummies, but it tasted like salt. But as you can see, that's a mummified banana. I could probably just keep this banana around forever. If I kept it on top of my refrigerator, it would be fine. But that's not what we're going for here. I almost just threw that, like, oh, I don't care. But that's salt, and I don't want it getting everywhere. The point is, I don't want a banana that's just going to sit around forever on my refrigerator. I want a banana that's going to sit around literally forever. In 100 million years, when people are digging through this earth, they're like, oh, well, why is all this debris radioactive? Oh, look, banana. So, the next stage, I'll just put that back there. Keep him dry, because it's super damp down here. I'm actually sitting in a puddle, which is not unusual for me, but it's not normal for me in my basement. It's the foundation here is multiple pieces, so it kind of leaks during the winter. Regardless of my leaking problem, the next step here is to imbibe is drink. So we're going to imbue, which is to anti-drink, the banana with preservative materials. Now the logic of that is it's a two-part process, because this would normally take millions of years. So I'm going to try to do it in like a couple days. The first step is to infiltrate all of the banana's tissues with a solubilized substance that is dissolved in base. The concept then being, I take another solubilized substance that is dissolved in acid, and then I put that one in second. Whatever's in the base precipitates out, whatever's in the acid precipitates out, the banana turns into inorganic salt inside. Not this kind of salt, but I mean like carbonates and stuff. Well, now you gotta wonder, well, what preservative insoluble substance dissolves in base? And that answer has already been answered. You've been watching, right? Haven't you? You actually haven't. I don't get views on these anymore, so it doesn't really matter. The answer is silica. I have this broken glass I broke earlier today. Unfortunately, it was one of my favorite drinking glasses, but I was stupid, and I broke it. But that does give me an opportunity. What is glass made of? Glass is made of glass, first of all, but primarily silica with a little bit of calcium. usually calcium. You can also have soda glass, which is sodium, and glass is actually water soluble. You may not notice that, but it is. Specifically in alkaline solutions, the silica will dissociate into, just dispersed silica. It dissolves. You can actually dissolve glass. Now, what do you need? You need a base. So remember my lye? Remember when I taught you all how to lye properly? It is not actually cake, because the cake is not a lye. That would be a terrible cake. That is a strong base. It's made from wood ash. If you didn't see the episode, it's caused by boiling wood ash with water to extract the potassium oxide and turn it into potassium hydroxide, which is lye. I have a pot that's full of that stuff. So the idea is that if I then take this glass and I dump it in the pot, now it will not dissolve like instantaneously here. We're not talking about a sudden reaction like salt in water. It's kind of spilling everywhere. This is the big piece, so that's going to go in nice and slow. It looks like this, in case you're wondering. The idea is to drop all this glass in and then boil the snot out of it. Literally, because that's what it should turn into, is something similar to snot, which will actually not be silica, it'll be sodium silicate, or in this case, potassium silicate. Probably. I mean, if this works. You don't necessarily need to use glass. You can use sand as well. Sand is made of silica. It's just a lot more impure in that it has other substances that'll add color. Okay, so that's ready to go. I'm going to boil that, and probably for a couple days. Not really. I don't leave the oven on overnight after what happened the last time. So I'm going to boil it for a couple hours, probably 10 or so, because I don't sleep much. But banana stays here. We do not boil the banana with the stuff. The stuff has to be prepared first. Then the banana will be dropped in and soaked until it becomes waterlogged. How do you know when a banana is waterlogged? Because it sinks. Same as a body. So, I will go do that, and then we'll see how that turns out. And the boiling, wow, that was fast. And the boiling is finished. It's still steaming. So the material isn't exactly 100% ideal. This is what it looks like. This is a sample I took. It's been warming for a while, so it's still hot, but this is a cool sample. As you can see, it looks a little bit like really weird apple juice, which is mostly the color of just how the extraction goes. Now, a way to check to see if this is actually valid is, theoretically, if I were to put acid in that, it would reduce the base and the silica would precipitate. So you can check that by adding a little bit of vinegar. Then swirl it up. And if it becomes cloudy and you see stuff forming, yeah, it's not really possible that you could see it because it's so small and so fine, but it precipitates out a cloudiness, like little tiny specks. Those specks are probably silica, which is what we want to be inside our banana. I mean, I guess if you were to just cool this stuff down and dry it out over time, you could probably grow some small quartz crystals. I don't have time for that, though. I got bananas that need fossilization. So let me not drink that, because it looks very similar to a lot of fluids I do drink. Not that fluid. What's wrong with you? So, let's pour out the solution into this vessel. I did remember to wear my safety goggles this time, because when I was preparing this, I opened the pot to look at it, and bleh, right in the eye. Almost in the eye. It barely missed, because I washed it out with lemon juice, and then my eye felt funny for a while. Now the glass doesn't really change that much. It is very hot. Let's see if I can touch it with my hands without getting burnt or cut. It's superficially not different. I mean, this looks a little different. That's just because it's dirty. It's been in that stuff. But it doesn't really actually dissolve. It dissolves a very small amount unless you were to use a really, really concentrated solution. Like thick with sodium hydroxide, like jelly. You're probably not going to get full dissolution. But this should be enough for my purposes. So let's dig out our banana. And there's the mummy. And set it adrift. Now how will I know when it's properly ready? It'll sink, because when a banana is dry, it floats. When a banana is waterlogged, it will sink, again, like a dead body. Not that I'd know anything about that, but we've just got to let that banana go now, and wait until it absorbs all the liquid, and then we can proceed to the next stage, which for you is probably right about now. And here I am again. The banana has bananaed. So I want to take a look at that. Well, I've already taken a look at it, but I don't think you've taken a look at it. It's probably been in this solution for about a week. Ugh. It has gotten uniquely firm. Like, it was dry before. Now it's sort of squishy and firm. Let me grab a hold of that. You will notice that the water has turned brown because, well, frankly, I don't know the scientific reason for that. Most likely it's because humans from the banana, not humans as in like those monkey things that wander around and get in the way of my car. I mean like humic acid has been released from the banana and caused a reaction creating weird, bizarre, semi-organic sediment with the potassium hydroxide. And there it is. That is a firm banana. It should now be soaked with a combination of, well, high alkaline solution and also silicate. Because I had dissolved glass in it, there should be dissolved silicate, potassium silicate inside the banana, theoretically. Now, if that's 100% true, it's hard to know. I'm working with household chemicals here. So let me move that banana out of the way. It's got banana juice on it. Not to be confused with banana oil. Banana juice and banana oil are very different substances. If you take a banana and you squeeze it, the stuff that comes out is the banana juice. Banana oil is isopentyl acetate. It's an organic ester that smells kind of like bananas. So the next phase of the banana operation is that we've exposed the banana to base and soluble minerals, or minerals that are soluble in base, which is, in this case, silica. I'm thinking now alumina would also potentially have worked if I dissolve some aluminum, but that's a little harder to do. So the next stage is acid dissolution. I've got myself my vinegar, which is my acid, and with that I'm faced with a bit of a quandary. So there are two different things that are commonly available to the household person that you can dissolve in vinegar that can then mineralize into a solid mineral that can be impermeated into a banana. One is calcium carbonate, obviously. Calcium carbonate is what eggshells are made out of, and it's pretty available. I don't have any eggs. I tried laying the eggs, it didn't work. I'm not a chicken. So I don't really have access to calcium carbonate in large quantities. But what I do have is this, bone meal, which I don't remember if I've used this before. I'm pretty sure I have. It's made with solar power. Also made out of cows and pigs, because that's what you do. After you slaughter a cow or pig, you've taken all the meat, you've turned whatever's not meat and not bone into hot dogs, then you've got all these bones. There's actually a giant machine called a bone grinder. It's probably on my list of top 10 machines I don't want to get caught in. That pulverizes all of the bone into a sort of homogeneous, powdery substance. It looks like this. So that is ground up animal bones. It smells very strongly of fertilizer. It's also got hair in it. Apparently these cows were black in color. Interesting. It's commonly used as fertilizer to provide phosphate to plants. The smell, to describe it, if you've ever been to an agway, I don't even know if agway is still around. Walk into an agway and take a big, steep whiff, and that's what this roughly smells like. The thing is, bones are not made of calcium carbonate. That's kind of a funny story. My father had to point that out to me when I was being stupid. It's like, well, you know, bones are calcium carbonate. It's like, no, bones are calcium phosphate. It's like, of course, bones are calcium phosphate. So that's a very different substance. Bones are actually made of hydroxyapatite, which is a funny name for hydrated calcium phosphate. It also interacts with vinegar. The famous experiment, which I may do eventually, of you can dissolve a chicken bone and turn it flexible. I mean, everyone has done that in like their 3rd grade class, right? Or seen Bill Nye do it. That's because you're dissolving the calcium phosphate from the bone in vinegar, but I look on the internet and nobody explains the chemical reaction of that very clearly. So I had to do a lot of thinking, and admittedly, I don't know inorganic chemistry. That's its own class in college, and as you know, I didn't do well in college. I did organic chemistry. Organic chemistry is very easy. Well, it's not easy, but it's so much fun. My favorite class in the college. Definitely not easy, but amazing. I really enjoyed that. Never really got far enough to do the inorganic part, though. So, this is what I believe the reaction looks like. Abbreviated in very non-chemical, non-scientific terms. So, calcium phosphate is calcium merged with phosphate. Phosphate is a combination of phosphorus and oxygen. Don't confuse it with phosphide. You'll die. Like, you will seriously drown in your own fluids if you're working with phosphides at this point. So if you picked up that jar of phosphide, put it back down and don't get it wet. Phosphate is harmless. You could eat this. It's in your body. It's what's in all organic things, even though people tend to forget about phosphorus. It's the very neglected bioelement. It's kind of like weird nitrogen, to be honest. So when you combine that with acetic acid, which is what is in vinegar, what that is basically hydrogen acetate. That's what acids are, is hydrogen of that. So that is a reasonably powerful acid. I mean, it's not aqua regia here, but they don't let me buy that anymore. So when you combine that, you get it switches over. So the hydrogen acetate or acetic acid protonates the phosphate to produce phosphoric acid, or hydrogen phosphate, you could also call it, whereas the calcium is dissolved away to form calcium acetate. Both of these are soluble. This is actually kind of a liquid, and this is it's a salty thing that forms crystals. It's white, usually. You say, well, you just mixed acid to make another acid? Yes. Acetic acid is a stronger acid than phosphoric acid, so it ends up protonating the phosphate to become phosphoric acid, which is soluble under acidic conditions. Well, it's soluble under all conditions, but it remains protonated under acidic conditions. There's an incredible amount of math that could be done to solve this about the pKa's and the dissolution constants. I learned that in analytical chemistry, and I don't really remember it very well because it was very complicated. So I'm just giving the gist of it here because I always like giving people the gist. The question becomes, what happens when you remove water from the solution? And that's what bothered me so much. I couldn't figure it out for the life of me. What happens when you take water out of this system? Well, the answer is the calcium acetate crystallizes into calcium acetate, and you're left with, residual phosphoric acid. I guess. That's not what we want. This is an organic acid, well, it's an organic salt, which do exist. There are organic salts. And it will dissolve if the banana is ever exposed for water. We want mineralization, non-water soluble substances, like we did with the silica. When the silica is put in these acid conditions, it'll precipitate into silica and it won't dissolve. A neat trick that calcium acetate can do is that if you heat it to 300 degrees Celsius, I don't know what that is in freedom degrees, it spits out acetone, which is very flammable. Don't do that around a flame. And it turns into calcium carbonate, which is a relatively insoluble substance. I mean, it is literally in my drinking water, but that's what we want to produce because that is mineral. However, then it gets complicated because what does this phosphoric acid do with the calcium carbonate? The answer is if there is any amount of water, this steals the carbonate becomes hydrogen carbonate, which decays into it's carbonic acid, so that decays into carbon dioxide and water, and the calcium is fused back again with the phosphate, producing calcium phosphate crystallization, or, I mean, when you get into phosphate minerals, it's a really complicated subject. So there are, I was going to say hundreds, but it's more like 10 different minerals that can form with calcium phosphate inside the banana. But that's what I'm going to try to do. That's the gist of it. Permeate the banana with solubilized bone get it into the banana cell structure, dry the banana out, cook it, convert it into calcium carbonate, and then keep cooking it, I guess, until it turns back into bone. Turn the banana into bone. The difficulty is that this requires dissolving bone meal in vinegar, which creates a substance that I've made before. I like to call it bone water. You might have heard me mention it periodically as the smelliest substance I've ever come up with, because I haven't done complicated organic synthesis with sulfur compounds, just mixing chemicals I find in my basement. It's a bad, bad smell. But I'm willing to tolerate it for you guys. So, you're going to need your bone meal. Throw that in a pot. Now, it won't be making the smell immediately, so don't get your hopes up. I do have to boil it. That's the part that's bad. When you boil bones in vinegar, oh, the reek. Alright. That's too much bone. Hold on, I gotta unbone myself. That's a pretty good amount of bone. Get your vinegar. New fresh vinegar, just bought it. Vinegary. Now you're saying to yourself, you dirty, filthy schmuck, why are you not doing the molar calculations? Because it's a lot of math work, and when you're working with bone meal, it's very hard to get it accurate anyway, because I don't know how much phosphate is actually in this, because there's a lot of collagen and hair and stuff. Mix that up. Oh, the odor. That really hits you. Yeah. A little more vinegar. I might add a little bit of water to that to get it up to volume. I have to boil it. I can smell it from here. Oh boy. I'll be back once this has boiled, and we'll be ready to transfer the banana into an acidic solution of dissolved bone. And the bones have boiled. Oh! I didn't even realize how bad it was inside the mask, because you're inside the mask, you know. Oh! Everywhere I go. The entire building. The basement. The upstairs. The downstairs. That weird floor we don't talk about. All of it reeks. Like, vinegar, fertilizer, but somehow it's spicy and fatty and meaty, and it's terrible. Oh, I hate that smell so much. Because it's right here. It just came off the stove. Bones, vinegar, a little bit of water. It reeks. It reeks like dead animals, but not like rotting dead animals, like almost food. That's the worst kind of bad smell, the almost food. Ugh. But anyway, I've washed the banana, rinsed it. It's still a little greasy. So, now I have to take this bone water, nice and hot. That's when you have the maximum solubility. Oh, opening it was a bad idea. Hold on. I'm gonna have to pour it. You may notice this sort of sludgy material in the bottom. That's cartilage. from inside the bone. It's really, really gross. I don't want to breathe it. I don't want to breathe it. But I have to breathe. Oh, that steam is pure stink. It's going up there. Oh. Oh. Okay. I'm going to finish this as quickly as possible because I need to get to fresh air. The banana is now in that stuff. The floating stuff, if you didn't hear me through the mask, is cartilage because bones are made of cartilage and hydroxyapatite. It's been stripped of its minerals. I don't know if you heard it, it audibly hissed when I hit the banana because it's acid interacting with the base. The banana is currently floating around, kind of sinking, foaming, already beginning to undergo a little bit of a color change to a lighter shade of brown. It's just going to sit in there until it's saturated. It's going to fill up with carbonates, it's going to fill up with this phosphate solution, and it's going to precipitate the silica, and then it's going to get fully permeabilized with calcium phosphate, and then we'll treat it from there. I have to get to fresh air. So, I made a miscalculation when I was making this banana. Kind of stupid. Should have seen it, but I didn't. And that previously, whenever I've been making bone water, it's always been filtered or processed somehow. In this case, I didn't do that. And it should have occurred to me that bone meal isn't just bone. Bone isn't just bone. Bone isn't just calcium apatite. Collagen, which is the protein element of bone. If your bones were just stone, they'd crack in an instant. They'd be too brittle. Your bones are mostly protein, which led to this issue in that the collagen dissolved and turned into the world's worst jello. So the banana has been entombed in jello for a week. Very, very disgusting jello. As you can see, it's kind of gotten pretty gross, but I'm going to extract it with a screwdriver. Oh, it is smelly. It actually looks like it started to decay a little bit. Let me rinse this off. It's super gross. Ta-da! And it's important not to smell your fingers and to keep that as far away from your face as possible, because that smells gross. So the banana is super gross, dripping. The skin has started to rupture. It's kind of starting to fall apart, which is unfortunate. Or is it? Because that just gives me more holes to shove minerals into. So, the next stage of this is to once again undergo a drying process in the salt, but this time at a higher temperature. Now my goal is to partially carbonize the banana. Anything in the banana that is organic, so cellulose, sugars, fats, any sort of molecules like that, will get cross-linked into carbon to a degree. If I put the temperature, I dry out the banana and then heat it up to maybe 400 freedom degrees in an atmosphere without oxygen or without much oxygen, it'll kind of harden. To do that, I need the salt. The salt, currently at about 400 freedom degrees, because my oven doesn't measure in Celsius degrees. Wow, it's really windy outside. Hopefully I haven't disturbed the salt demons. But anyway, you don't want to touch this with your hands. Salt is like glass. It looks the same wet as it does cold. That's not the saying. I don't know the saying. So, banana gets buried in here, back into the mummification process. You can hear it sizzling. That'd be your hand if you touched the salt. You'd sizzle too. Buried in hot salt. So, to summarize what heating will do, one is the carbonization. It's getting angry in there. One is carbonization. Well, one is drying. The banana will lose its moisture and all of that bone water. Two is carbonization. Any carbon left over in the banana in form of sugar or whatever that isn't bone water right now will convert into solid carbon, like charcoal, to a degree. More like caramelization, which is kind of a gross way to phrase it because it's not going to taste like caramel. Additionally, all of the calcium phosphate, as discussed previously, will reconstitute as calcium phosphate in theory, and that should complete the majority of the mummification process in this particular banana. But, in the interest of making sure and being thorough, I'm going to go a little bit further. So that'll be the end of this video series for the first part of banana preparation, which means you don't get to see the finished banana at the moment, because I'm going to redo all of it again, better, to get a second pass. And we're going to cover what I did wrong and what I can do better. And it's going to be just as interesting as this, which is to say, not very much. So you're going to get a temporary extra, and then the next one will probably be available next week. But since nobody actually watches these, and if you are watching them, I probably posted them like 7 years ago, you can just skip to the next one right now.